Hello and good morning to one and all present here. I, Asia Qureshi from the Department of Information Technology of Sheth, L.U.J and Sir M.B. College of Arts, Science and Commerce would like to welcome you all to the webinar on industrial application of cloud computing. I would like to take this opportunity to welcome our Honorable Director, Ma'am, Mrs. Jyoti Gaitonde. It's an honor and a privilege to have you here with us today. I would now request our Director, Ma'am, to enlighten us with a few words of wisdom.
Good morning, everyone attending this webinar. At the outset, I thank and welcome Mr. Sudhir for agreeing from his very busy schedule to address this webinar. We are really honored by your presence. As he has number of years of experience with TCS, over 25 years of experience. I'm sure we all will be enlightened by his talk and the information that he gives. I wish all the success for the webinar and thank you so much.
Thank you so much, ma'am. I would also like to welcome our Principal and HOD of Computer Science Department, Dr. Mahendra Kanodia, sir. I now request sir to enlighten us with a few words.
Good morning to one and all. Proud to see that our whole meet is full and we have to join together. Like I and Director Ma'am, we are all both joining from the same meet. So welcome to all of you students, those who have joined from other colleges, our own MVLU college students. Also welcome to teachers of college and the teachers, those who took a time and been attending this session from the other colleges also. Welcome to our resource person, Mr. Sudhir. He has taken up time. He has, he's been an design architect or enterprise architect in the TCS Mumbai and having more than 25 years of experience. So we are honored to have him with us as a resource person. My best wishes with Ms. Neha Kokenekar and her team, the whole IT team, for conducting this webinar. I hope it becomes a fruitful session for everyone. We will definitely understand how this cloud computing techniques are used, its applications in the IT field. Whereas more of the IT students, undergraduate IT students, they don't have this topic in their syllabus directly, but it has a very big impact right now in the industry. So I think so this gap would be definitely bridged today with this session, which has been organized by the IT department of MVLU College. My best wishes to all of you. See you. Thank you. Thank you so much.
Thank you so much, sir. I take this moment to welcome our respected guest speaker today, Mr. Sudhir Manohar G, and also the teaching and non-teaching staff along with all the participants. College is a place where a student develops his or her personality and various skills. This helps in escalating students' maturity levels. The college environment then becomes a major factor behind shaping a student's mindset and enhances his or her perspective towards the world. So, let's have a look at the infrastructure and environment of our college and get to know more about the college. As you can see, this is the history of our college. Our college was established in the year 1963. It is affiliated to the University of Mumbai. This is our esteemed trustee, Mrs. Aarti Visanji. Ma'am has a mission to provide progressive education to undergraduate students. Meet our Honorable Director, Ma'am, Mrs. Jyoti Gaitonde. She is truly a living example of leadership. I would like to introduce the Principal and Head of Department of Computer Science, Dr. Mahendra Kanodia, sir. We have our organizing committee present here, which includes Assistant Professor Sneha Gokarnakar, Assistant Professor Rohini Jagdade, Assistant Professor Marina Ghivargis, and Assistant Professor Sumit Kumar Tripathi. I would now request Neha ma'am to enlighten us with a few words.
Hello, am I audible?
Yes, yes, yes.
Hello. Yeah. Very warm welcome to all the participants. Our management, Madam Director, Madam Gaitunde Ma'am, and our beloved Principal, Dr. Mahendra Kanodia Sir. Thank you, sir, uh, for permitting us to organize such a webinar in intercollegiate level. Uh, we are glad to have our resource person, Mr. Sudhir, and he will be exploring us with the new technologies under cloud computing. Hope you all will enjoy the session. Okay, over to you, Asia now.
Thank you so much, ma'am. These are the four self-finance degree courses available in our college: Information Technology, Biotechnology, Computer Science, and Mass Media. Our college has two air-conditioned auditoriums, one on ground floor and another one on the first floor. Our food hub, which has good ambience and good quality food at a pocket-friendly price. Special care is taken to make sure that this place is always sanitized and hygienic. College has a huge playground for sports lovers. All our outdoor sport events like cricket, football, basketball, etc., and also fairs are conducted here. As you can see, there is also a tennis court provided by our college. We have a gym khana for girls and boys on our ground floor. All our indoor games are played here, like carom, chess, and many board games. For book lovers, there is a huge library. Our vast library has a distinct section for IT oriented books. Our IT and CS labs are fully fledged AC labs equipped with high end systems. They are on the ground floor. This is the biotech lab situated on the second floor. This is our media room situated on the first floor, integrated with high tech computers with graphic cards and graphic processors. As you can see, this is our spacious and well maintained classrooms. Our college has a certification center called MVCC. You can visit and explore more about it on its official website www.mvcc.com. There is also a Google certified course of digital marketing offered by our college. Moving on, let's meet our esteemed guest speaker, Mr. Sudhir G, a distinguished software engineer with over 25 years of experience at Tata Consultancy Services in Mumbai. With an impressive track record in various sectors like banking, telecom, logistics, retail, and CPG, high tech, he brings a wealth of knowledge to the table. His expertise as a solution architect, along with product development and program management, has led to the successful execution of numerous complex projects for international and domestic clients. Notably, as a certified Google Cloud digital leader and contextual master, he possesses a keen understanding of leveraging cloud technologies to drive innovation and business growth. Join us in as we learn from his rich experiences and gain insights into the ever evolving world of technology. Sir, I would now request you to take over and begin with this webinar. Thank you. Sir, I think your mic is off.
Yes, are you able to hear me now?
Yeah.
Thank you for the warm and notable introduction,
Yes, yes, sir. Yes, sir.
Asia.
I'm audible. Yes, yes, yes. Yes, I am audible.
Okay. Respected Director Jyoti Gaitonde ma'am, Principal Director Mahendra, the professors and support staff, thank you so much for giving me this opportunity for having this session on cloud computing and its industrial applications. I'm highly obliged to interact with the student community. It's been quite a while since I have been in the same line 25 years ago. So I'm really excited to connect with this young generation. And I hope all of you are also excited in the today's session. Let me quickly share the deck which I am intending to present and discuss about the key nuances of cloud computing and its applications. Just give me a second. Let me know if you are able to see.
Yes, yes.
Okay, so today's topic is on cloud computing and its industrial applications. So let me give the details of the agenda, what I intend to discuss upon. Firstly, we will talk about cloud, its types, and its services. Based on the foundational understanding, we will talk something about regions and zones, which is very peculiar to cloud computing. And then Kubernetes, it's basically something on an container orchestration technology. We will speak about it, what its architecture is, and how it is used from both development and usage perspective. Uh, Briefly touch upon certain security, key security principles as well, and then followed up by the pros and cons of cloud computing, and then its industrial applications, and for the student community, certain certifications also, which could be useful for them in case they are intending to certify themselves. Okay. So, firstly, what is cloud? I hope you have come across this term multiple times during your peer discussions, during your college discussions, across professors, lectures, and maybe within your family also. You could have certain relatives who would be involved in some of these projects which are on cloud. But what exactly is cloud? We have heard about it. Of course, there is a definition to it, but we definitely need to understand what the concept is about. Now, if you see, its a definition is cloud in IT is the on-demand availability of IT resources, which is infrastructure and services over the net with pay as per use pricing. While this is the definition, but I think from a student point of view, it is important that they understand the concept as well. Now, what is on-demand availability here? If you see, this is the key term when we talk about cloud. Now, if you look at it, when you say on-demand availability of IT resources, which means in a business corporate industry, if you see, there are certain applications which are available, but the usage is not consistent throughout the 24 hours of day. It could be peak period, it could be slack period, so and it could be festive period, it could be some promotional events which could be happening, right? So how do you provide your solution so that it can cater to on demand availability? So when there is a surge in terms of the request or in terms of the access, you definitely need additional resources. And when there is a slack, which means there are hardly requests coming in, so which means that you need not have all the resources up and running because it is a wastage of resources. Okay, so how do you profile this in terms of scaling up on demand and scaling down when the demand is low? This is the basic principle on which cloud operates. So hence what is mentioned is on demand availability of IT resources. The second key term here, if you see, is IT resources. Now, what exactly are IT resources? We might have a basic understanding here based on what has the students have gone through certain curriculum. Okay, but IT resources is not just software. Okay, the software is executing on certain server or infrastructure, what we call about. Hence, when you talk about IT resources, it's fundamentally the combining both. You need to have certain infrastructure which will be set up, and there will be software which will provide the services to you. So this is what is available in the cloud computing. The next key term here is over the internet. So what is the access channel here, what we are talking about? Okay, we always use our mobile apps, or we might be connected to Wi-Fi, or for that reason we might have some internet connectivity at our home. Now, using that as an access channel, if we can access the IT resources on demand, okay, then this is a combined, I would say, a definition for cloud. And most importantly, everything comes with a cost. Okay, the more we use it, the more we have to pay. But however, if we use high infrastructure when the demand is low, then we are not optimizing our cost in there. And cloud also provides this key feature: pay as per use pricing. So if you see, there are four key terms what we spoke about in cloud definition. It's on demand availability of resources, and using internet as a channel which is widely and globally available. Okay, and then you pay only as per you use. I hope this definition of cloud is clear, and let me move to the next point then, just detailing out what the resources are. When we talk about infrastructure and software, let's look at some of the terms which we might be familiar with. Okay, these include something like servers. Now, servers could be high-end servers. Servers could be for very high analytics, okay, or computational needs. So there could be different versions and different server combinations in terms of the capacity, in terms of the size, in terms of the computing power and the nature of it. Along with that, the networking. The network is also part of infrastructure. Now, what do we mean by network? We will have certain firewalls, we will have certain network switches, we will have cables connected, we will have chassis where the servers will be hosted. All that is part of your network backbone. Along with that, we also have certain databases. Okay, databases, we might be familiar with RDBMS, but since the evolution of technology, we also have something high-end databases in terms of architecture. You're supporting both SQL and non-SQL. RDBMS is one concept of it, but we also have data lakes wherein huge amount of data. What I'm talking about, huge amount of data, I'm talking terabytes and petabytes of data about that. So all of this, if you see, it can be hosted in the IT resources for a cloud. Along with that, data storage capacity. Now, data storage can be a SAN storage or a NAS storage. You will have high-end storage connected to your network, and then there will be different applications which can consume data from the storage. And of course, lastly but not the least, the softwares. There are so many applications, there are so many softwares which are available for us, licensed version, open source versions, on which development is done and deployed, and then the application itself is available as a product to the end consumer. So in this case, if you see, we are connecting the IT resources with the whole gamut of resources, whether it is hardware or a software or a networking or a database, when we are talking about cloud. And all of this is available when it is hosted as a cloud. Okay. Now, I spoke something about a term called high-end computing. Now, what is high-end computing? Let me give a simple example so that we can understand. If I have a 32-bit core CPU core machine, or a 48-core CPU machine, right? Or I will have a 256 GB RAM and associated with that terabytes of data. Now, this is a single server. I cannot afford to allocate all its resources to one application. So I'll need to split this high-end server into multiple instances. How can I achieve that? There is a concept called virtualization. Now that brings me to the next topic. What is virtualization? Okay, virtualization is basically a way to simulate or create a virtual environment based on your actual physical environment. Now the diagram here, if you see, it's basically an example of a one server machine which could have an hardware. That's principally it is delivered to us when we procure any kind of a hardware. But how do we build up the hardware? First and foremost, we have to deploy an operating system on that. Okay, so that the hardware what we are talking about is functional, which means that humans can interact with the computer here. And then how do we create a virtual instance out of it? So we have something called VMware, Citrix, or hypervisor. So if we have this kind of a hypervisor, it provides a mechanism wherein we can create virtual machines. So this hardware in itself will be a high-end server, but however, I'm creating individual instances which are called as virtual machines using the hypervisor on the single server. Now I can have such multiple things, and I can have different applications which will be executed as part of the virtual machine. I hope this concept is clear, because based on these fundamentals, the cloud computing and the way to consume the services using the resources of cloud are based upon. Let me move to the next slide now. We will talk about types of cloud. Okay. What is the first and foremost type of cloud? Private cloud. I think this is the very fundamental thing which everyone would be aware of. Now, what is private? It is not available for public usage. It is for a corporate who have hosted it into their data center, and hence the term it as private. So nobody else other than the corporate and their users whose privileges are available or who have the access to consume these resources will be use the servers and services available on this infrastructure. There is a term called on-premise. Okay, so whenever a corporate has certain kind of an infrastructure which they are hosting, and this infrastructure is very huge. Okay, just think about a data center where hosting hundreds and hundreds of such servers which are in a cluster. Okay, so there is a huge amount of capacity, storage, computing power available in them. All this is hosted in on-premise model. So the data center, what we usually call the term for hosting an on-premise infrastructure, is under the control of the corporate itself, and that access is enabled only to the selected set of resources or privileges who they have provided. Now the problem with this is, this being private, everything has to be managed and procured, managed and governed by the corporate itself. Now let's say, what are the challenges here? The first and foremost challenge is, I definitely need some real estate space so that I can create a data center. So you have to invest in real estate. The second is, you have to procure based on your capacity. Now you will have to figure out how much of user base you will be supporting. 1 million user base, 10 million user base, 100 million user base, 500 million user base. Okay, so based on that, you will have to do a capacity sizing. Now, and the capacity sizing will tell you that how much of infrastructure you will need. Now, this is the service capacity you are looking at, but there are certain add-ons as well. Like, you will need cabling, you will need the racks, you will need the chassis, you will need AC, you will need UPS, and many more things. All of this you have to think before you can decide and invest to create a private cloud. And hence, the capital expenditure in this case is very high when you talk about a private cloud, which is on premise. All of this has to be done considering the investment, considering the time to procure, and obviously the additional time required to set it up to make it functional before any kind of a development of product can happen or an application can happen which will consume this particular infrastructure. So cost is primary, time is another element, key element, and obviously the time to go to market. There is a huge amount of competition in this world. So anyone who has to achieve a success in their business, they have to always be first in the market. Else they will lose on their to capitalize on the market and business in there. So if you talk about this, there are so many challenges. So what is the alternate option? This cloud concept has been there for almost a decade back, okay, wherein a lot of research the industry has done, and what they have come up with something called a public cloud. Now we might have heard some of these key terms, okay, something like Google, something like Azure, something like AWS, Amazon Web Services. So all of these, and these are not the only ones, these are the key ones. However, there are some additional ones also who are slowly picking up the pace. Oracle is doing, for that matter, the company I'm working on, TCS, they also have a cloud, okay, which is available for public. When I say public, it is for the customers for whom the development is happening upon. Now, these are the names I have called out: Google, Azure, AWS. You might have heard about these names, but they fall under the public category. What is public here? Now, we will look at some of the services which the public cloud provides, but the basic principle here is whatever challenges I called about in the private hosting of a cloud, okay, is addressed by the public cloud. Now, Google has done it, Azure has done it, Microsoft and Amazon Web Service has also done it. TCS has done it, Oracle also has done it. So everybody has done some kind of an investment, setup, data center hosting to provide services for different business corporates for their kind of engagements. While we talked about private and public, we also have a third category, which usually we talk about as a hybrid. Okay. And as the term states, hybrid is a combination of private and public. So a customer might have an on-premise infrastructure, and it's not easy to do away with that because you have done so much of investment, you might have used it for a while, and suddenly you say that let's discard all of this infrastructure and move or migrate to a public cloud. That does not happen because primarily the cost and the timelines and the stability of their application is involved in. Okay? So what they think about is whichever is easy to migrate, whichever is convenient, whichever is less time consuming, let's focus on those areas first to make it on a public. And they continue with the private infrastructure what they have hosted upon. And that's the reason we have something called as a hybrid nature. Over a period of time, from private, they can move completely into public, or they can continue to be in this hybrid model as per their business engagements are involved. Okay, so that's the concept on types of cloud. We have private, we have public, and hybrid. Now let me go ahead with the next concept in terms of types of services. Now we are hosting a cloud, so every cloud service provider will provide certain kind of a managed services. Now, of course, we will look at each one of them. The first one is infrastructure as a service. Now, as the name itself, if you see, what service are they providing? Infrastructure. Okay, in this case. So it's easy to remember for the student community also when we talk about infrastructure as a service, IaaS. That's the acronym for it. Okay. And if you remember infrastructure, you'll definitely recollect what this is associated with. What is it? It's a collection of physical and virtualized resources, which offer what? Compute, storage, and networking resources. As we have already seen some of the virtualized and the resource details in the first slide we spoke about. Now, how is this different when a cloud service provider is providing a service? So if you look, there are two grades of color here. The one beneath here, which is the network, the hardware, and the virtualization. This is the responsibility of the cloud. Okay. Now, whoever cloud this could be, but when we talk about infrastructure as a service, these three parts are responsibility of the cloud provider. Now, if any corporate has gone for an IaaS kind of a service, then they will definitely have some subscription and licensing and cost and payment model associated with the cloud provider for these three parts. Okay. Once they have it, what is the next thing they do is they will be installing their OS, okay, whatever flavors of OS they need, the application runtime and the application. So all of this development would be the responsibility of the corporate or the organization who is going for an IaaS model with the cloud. I just take a pause here so that student can realize what we are talking about in terms of an infrastructure as a service before we bring in the next type of service. So just focus on this, that whatever physical infrastructure or a virtualization of the resources is possible, okay, which will offer them compute, storage, and networking resources. Okay. So the next type of service is PaaS, PaaS, and the acronym stands for Platform as a Service. Okay. Now, of course, it's a different from infrastructure as a service. And it's easy to note that when we talk about infrastructure as a service, now again there are two shades of the color, but whatever is beneath this is the responsibility of cloud service provider. Okay, so from application runtime to network, all of this will be provided by the cloud, and the corporate or the business will have to only focus on application. So they will have certain kind of a licensing agreement, subscription, and payment model associated for these five parts. Now, what is the definition for it? PaaS is a complete development and deployment environment, which offers development teams to build, test, deploy, and scale applications. So any kind of application you are developing, okay, the application runtime and the OS required for it and the infrastructure required for it will be provided by the cloud. You can only focus on how you want to develop, which languages, which databases, what is your architecture that you focus upon and build your application, and then it is easy to deploy. The environment is made available by the cloud. And there are two varieties of it: function as a service, container as a service. We will talk about these container especially when we go to the next slides. But for your understanding, function as a service means uh, it's a small kind of a function instead of an entire application we are talking about. It's a variety of paths. Only we are talking about a function instead of applications. Think something like if I'm giving you a picture, it should tell me what that picture correlates to. Okay. I will just quickly develop a function and deploy it on this particular model. If I want a speech to text, I can build a function and that will quickly create the text out of the speech and I will deploy it. So it is very simple to deploy, easy to develop, test, deploy, and then if I have to scale based on the user base, then I also have an options to go on demand basis. Allows customers to execute code in response to events or requests. The next category is a container as a service. So what happens here is it's again a variety of PaaS, and we are deploying applications in container mechanism. We will talk about containers in the next slide, but just look at if you have to manage containers, then you can easy to start a container, to stop a container, and you can configure how you want to scale up, how many containers you need to support a certain user base when you expect a peak demand. So that kind of profiling is possible using container as a service. The next is software as a service. Now, software as a service, it's basically a collection of softwares which is available to you to access. Okay. Now, in this case, if you see the entire stack is provided by the cloud. Something like, let's say, Gmail. To access Gmail, you just need to sign on, and the application is available to you for receiving and sending email. So the entire infrastructure along with software is available as a platform to you. Software as a service. Okay. Now let me take a real life example here between on-premise and hosted on the cloud. Let's say you buy a car. Okay. You are investing in that car, you are investing in the infrastructure, and that car belongs to you because it's registered on your name. It's an example of on-premise, which is a private. Okay. The second is basically leasing a car. You are leasing an infrastructure here, which in this case is a car. Okay. So it's an example of IaaS, infrastructure as a service. Now, platform as a service, taxi, like you have these Ola, Uber, which provides you a booking mechanism as per the schedule, as per your need, and pickup and delivery point. All that is available as a platform to you. What you do is you use the platform, book for a taxi, and it is at your doorstep, and you reach your destination through traveling through it. That's an example of platform as a service. Now, what could be an example of software as a service? let's take an example of train or bus, right? All of these are software as a service because the travel mechanism is already made available to you. You just buy a ticket, board the train, and reach your destination. So that's kind of a real life example or a mapping for students. If you want to quickly recollect sometimes how are these different terminologies associated. And last but not the least, serverless. Okay, as the term says serverless, it actually does not mean there is no hardware or a server involved here. What it means is you as a consumer for the service available from cloud, you don't have a visibility into the infra. Whatever infra is available or provided by the cloud, but you don't know what that is. You will not be able to access it. What you do is you have a code which you deploy, and that code is basically to serve requests, and you pay only for the request. How much of request? If you have million requests or more than that, you pay only for the request, on demand and low demand. Okay, so that's the mechanism of serverless. Now let me take you another concept of regions and zones. Now we talked about data center, we talked about the infrastructure, we talked about the software, but how does a cloud service provider provide this? Now they have a concept called regions and zones where the infrastructure and the services associated with it are distributed. Let's look at the fundamentals here. Now let's say you have a data center and you are hosted that infrastructure in Mumbai region, and there is some application which it is serving. Now it is the application is working, there is no issue with it, but the challenges which could surface here is high latency or slow access from other parts of the world. What does this mean? This infrastructure is hosted in Mumbai region. Now let's say if you are outside of Mumbai region, okay, any other state other than Mumbai or Maharashtra, so you will experience that it will take time to access this. It's similar to what your mobile network is. The more closer to your uh, uh, BTS are BTS, okay, base station controller, uh, and antennas, right? You have a very high I would service available or the network available. The more you move away from the BTS, it slows down your connectivity. Why is that? Because of the latency it brings in on the network. The distance for a packet of traffic to travel from your source to destination is increased, and the BTS will have a certain radius in which it will be able to provide services and connectivity to you. The moment you go beyond that, you will have a drop, so your network will be lost. So that's the reason it's a slow access from other parts of the world. Now, low availability of data center. Now, let's say for any reasons, this data center goes down. It could be a natural calamity, or it could be some issue in the network or component, or it could be an issue in the connectivity to the network. Okay, what happens? There is a data center crash. So if a data center crash, what does that mean? The application is not available. It's a downtime for the application. So this is a challenge when you have a single region and you have an infrastructure. Of course, the application is working there, but these are some of the possibilities which can prevent you from providing continuous service. So what do? You need to bring in something called high availability. What is high availability? Now, same Mumbai region, okay, let's say I have two data centers, data center 1, data center 2, and hosting the same kind of an application. So what will happen? Let's say if data center goes down, I am still able to service based on the availability of data center 2. So what am I addressing here? I'm addressing this low availability data center crash. But am I addressing this? No, because both are still hosted in Mumbai region, and anybody accessing this application outside of this region may face a high latency, or maybe even sometimes if the network is too slow, it may not connect and time out. So what do we build upon? We replicate across regions. Now what we have done is we have created another region here, let's say it is the Chennai region, and there within the Chennai region also we have high availability, and across regions also I am bringing high availability. So if my entire Mumbai region is down for any natural disaster or for any reason for that matter, I can still service the application from my Chennai region. So yes, these are the building blocks, how you set up your data